Hey guys, today we will learn more about some spatial analysis. In order to do that, we'll have to have the basic understanding of a projected coordinate system and geographic coordinate system, which are the two coordinate systems ArcGIS works with. So let's talk about GCS first, which is geographic coordinate systems. As you can see, the Earth is divided by these imaginary lines, which is equator and prime meridian, and prime meridian denotes the longitude and equator latitude. So let's take a point somewhere here, uh, and we'll see that these numbers it represents the latitude and longitude. The first part is latitude 23 point something, and second part is longitude. What latitude is a point from the equator. It could be either this south or this side on the north, and the whole north, all the way north 90 means in the north pole, and all the way south is south pole from the equator when we talk about latitude, right? So this number is 23 point something. That means the line is situated somewhere from the somewhere north from the equator line, since it's a positive. And I will give you another example. Like, this is the equator line, and we if you click here, you will see a negative value is negative 2.299. That means it's on the south side. So for Bangladesh, we can see that it's positive, which is a north side of the equator line, and 89 represents the prime meridian, which is located here. The prime meridian line is somewhere here. See this England thing on the map. Yeah. So this line is like a vertical line, imaginary line here, and from here, if we see, we'll have the negative value for the second value for the prime meridian line for the longitude, and here we'll have the positive value for longitude. Yeah. So that means we are so for Bangladesh, which is, sorry, I forgot, maybe 89. Yeah, 89. That means it's somewhere east side, somewhere east side from the the prime meridian line. Yeah. So why do we need a projected coordinate system? So that's the question. The GCS, geographic coordinate system, is best for visualization or storing data, right? Like this, all the things we see online, the maps, it's all it's all made with the geographic coordinate system. It's better, and it's easy to visualize data here. But when we want to do some measurement work, like measure distance or measure area of our study site or somewhere, we'll have to use the projected coordinate system, because the earth is, as we can see here, round, but it's not very round. It's like a sphere, right? So when we want to work with our measurement, we'll have to make the earth as a flat surface. But when we flatten the earth like this, it's always distorts. We will not have like an actual length or actual area of anywhere, because the earth is distorted when we flatten it, right? So what we do is we flatten earth and create our own coordinate systems for a specific region. Like for PCS, which is a projected coordinate system, we will not have one single PCS that covers the whole earth, because earth is very irregular. You will not have the exact same measurement, same distance or area with the same coordinate system everywhere. So this is why PCS are used. So remember that always works in specific region. There are many PCS for many locations. Yeah, so let's go to ArcGIS, and we'll see this default by default this map. And I have turned off the hill shade because my PC is not, it takes time to load. Yeah, so in order to see which coordinate system we are in, let's go to let's right click on map and properties, and let's go to coordinate system, and we will see that by default it has a WGS 984 wave marketer auxiliary shift auxiliary sphere. And what marketer means is, it means this is a PCS coordinate system. But I have already told you that PCS is mostly for, PCS is for this is very region based, specifically designed for specific regions, and it used to is to measure distance or area or whatever. But here we can see that it covers the whole map as a whole, the world map as well. But when we want to when we measure something using this coordinate system, we will not have the accurate result, not even close. Yeah, so what we do is we whenever we want to some visualize data or store data, we use this we use geographic coordinate system, right? But when we want to use when we want to work with measurement, we go to PCS. Yeah, so let's give you an example. For Bangladesh, we go to projected coordinate system, and WSN Northern Hemisphere. And for Bangladesh, the best way to the most accurate results are comes are come the most accurate comes from the PCS is here, WGS 46 north. Yeah, so when we open this, you'll see that we'll have only a specific region, like let's give it a minute. Yeah, so you'll see that only this part of the map is loaded, right? So as I've already told you, because PCS is region specific, right? So what which PCS do you should use? The question is which PCS you should use for your work. So maybe there will be you can find it on internet. You can search around, like for your study site, which PCS is best suitable, or use a PCS that have your study region on the center. Like the more you go on the edge, uh, you will most likely to have less accurate results. So as you can see that this Bangladesh or India or this region is centered on this PCS. Yeah, so I think that's it. So you already got the idea when to use PCS or when to use GCS, and maybe you'll have some guideline from the government, or from your client, or whatever you work for, which coordinate system to use for measurement works. Yeah. So let's go back to a GCS, right? So uh, mm, I'm sorry, let's give it a minute. Yeah, let's add some data here. Let's open this NYC motor vehicle accident from January 2022. And you can see that we have already discussed, when you import something, it imports as a standalone table. We'll have to use projection, which is a display XY data to, in order to show the coordinates on the map. Let's Yeah, it's already taken the latitude and longitude field. We have already discussed it. Let's change our base map into street. Am I recording? Yeah. And we will do some measurement work on this map. So we'll have to change the map as well as the table, as these coordinates into a projected coordinate system. You already know about the map. We'll have to go to the properties, and since it's somewhere in New York, and the thing I saw, that guy, which is very nice, I shouldn't call him that guy. He used a coordinate system that suits perfectly or more accurately with New York City. He used projected coordinate system than continental North America, and he used um, this NAD 1983. No, 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 not this. Contiguous. This one. NAD 1983 2001 contiguous USA Alpers. This one, and it will change the map into a projected coordinate system map. Please fast forward a few seconds. Yeah, so let's not wait for that. And now we have transformed the map into a PCS, projected coordinate system. We'll have to change these coordinate because we have imported them as latitude and longitude. So we'll have to transform them into a PCS system as well, right? So in order to do that, we'll have to go to we'll have to use a georeference geoprocessing tool. We don't have the geoprocessing catalog here. No, no, just have geoprocessing pane here. So go to the view, geoprocessing, and search project data management tool. Input dataset, the dataset we want to change, and change it into, let's give it a name, PCS. And we can use this button to change into any PCS we want, or we can use this drop down menu and use current map, since we already changed the current map into PCS, and then run, obviously. Yeah, so that's it. Let's unmark this, hide this. So now we have a data set and a map which are in projected coordinate system. Now we can uh, do the measurement works in with these coordinate and in this map with much more accuracy. I think that's it for today. Maybe not today, I'm gonna record another video. So yeah, for this video, that's it.